So today I wanted to try to show a good example of how pre-staging GIS data can help you with your immediate calculations. And it's really kind of hard because you don't see what's behind it. You don't see the work that goes into pre-staging these layers. And one of the best examples of that, and one we're going to use today to create and calculate a BFE, although a non-regulatory BFE, is the USGS StreamStats portal. Now, I've got it pulled up here already, and I'll have a link down in the bottom. But I got a location I would like you to use too. I'm going to put those in the links too, just in case you want to go through the whole thing and try to do it also. But we're going to paste those in here, and it'll take you to these coordinates, and it's in Ohio. So you want to select Ohio, and then we delineate the watershed. So, and this is where the pre-calculation, this raster layer down here with all this data associated with it that you actually extract information from when we do this. So I'm going to hit delineate and go over there to this point and select it. Okay, it says it's valid and it's delineating it. Now there's a lot of states that have this information. StreamStats, they're wanting to develop it for a nationwide effort. West Virginia doesn't have these. So we're going to be doing a lot of these same things, but we're going to be doing them a different way. Manually, so to speak. So look what that did. That calculated the whole basin, and now it wants to do even more. It wants to it wants us to download the basin, which we're going to do. But I'm going to hit continue right now because there's an option to download it later. I'm going to go ahead and click peak flows, because peak flows is what we use to calculate a base flood elevation. So then I'm going to move on down and hit, it asks for basin characteristics. And this, look how much information is on there. It just has, it has a percentage of land coverage and of different types of impervious and percent forest. It's really amazing how much information is contained in this little layer, and you're able to extract. But in this case, I've selected peak flow, so I'm going to hit continue. Calculating selected basin characteristics. So here it goes. It's doing it. There it goes. Look at that. And here we are. We're selecting the characteristics and scenario. I'm going to hit continue. And here it is. That's the report. We're going to be using the slope from here, and we're going to be using the drainage area in square miles, and we're going to be using the 100-year peak flood. If you scroll on down to the bottom, you want to download the basin, and I typically do it as a shapefile. And here it says it's waiting to download, and there it is. It downloaded it, SSOH with a unique ID number. It looks like the date on there. And then I don't need the CSV file because it's more or less a bad formatted spreadsheet with this information. What I want to do is I'm just going to save this. And generally, if I hit print, my computer's set up to print and save PDF files. So that's what I would want to do. And I've actually already done this on my desktop. And I would save it to my working directory that I'm working in. So let's just say I did that. So now we got a lot of information, and I've already put this information just from that web portal, from our specific location. Here's the working directory that I put together to do this. So next, what I want to show you in on this particular web portal, and this is another good example of how they could be used. I really think the BFE process could be self-contained within a web portal, just like this. Because right now, we have everything we need to do the BFE calculation, except for a cross-section. But even that's in here, because I can actually hit this exploration tools and hit elevation profile, tell it I want the finest quality DEM information, and hit select points. And I can actually go to that location and put a cross section there. Look here, it's querying elevation data. And here it is. So this is that cross section, and it's very typical of how we would do a cross section for a regulatory BFE. The thing I don't like about this, even though it uses the finest data, and I'm thinking that that's a really good elevation information, and it's just as good as we're going to use to calculate the regulatory. But the problem I have with it is these station distances are in miles. Well, that's just not good. I mean, you can't use that. I mean, so I'm not even going to show you that. I mean, I'm going to show you the way that we're going to basically be doing it for our tool in West Virginia, where we calculate a regulatory floodplain, or base flood elevation, I'm sorry. So let's do that right now. So to do the information and to get that cross-section information, what we need to do is to go to and download a really good DEM data. And I'm going to use that same location, except this time I'm going to use this one where the coordinates are reversed. Some portals like coordinates, you know, X and Y, and some like them Y and X. So I'm going to just paste them in this search location here and hit go. It takes me right to the same location, except in this case I'm going to hit this draw point, and I'm going to click it, and then it hooks to my cursor, and drag it over to that location and hit select. So then what that lets me do is I'm going to go over here. That's my search area. So I'm going to change these elevation products. I'm going to change it to the 1/9 arcsecond, which is the most accurate. Actually, the 3-depth was probably more accurate, but that's basically raw LiDAR data, so we don't need to search for that. So I've set this point, I've selected 1/9 arcsecond, and I'm going to hit Find Products. And this is the DEM for that location. So I'm going to download it. And this is the same way. It goes down into your download folder, and then you bring it into your GIS system. So we're going to go ahead and I'm going to open up my seed file, my GIS seed file that I'm going to use on every project, except for this time. This is just for this one. It doesn't have all my pre-established GIS layers. We're going to kind of get a feel for how it is to manipulate the DEM and how we actually calculate a BFE. So what I have attached here is the DEM that we were just downloading. It actually hasn't finished yet, but I've previously downloaded it. And so this is it. Look at all that information, every point on there. And if I look at the information in the properties and the information window, you can see how accurate it is. This is in decimal degrees, but it's like 3 meters. And we can know more information about this if we go to the actual metadata that's associated with this file. So if I go to that metadata where I unzipped it and look at the HTML, we can see what this DEM is all about, how accurate it is, how it was produced. One of the things I want to point out is the elevation data. Here, it's in meters. Altitude, distance, unit meters, vertical, datum. It's in meters. Here it says geographical coordinates, decimal degrees. So this is where you find out all the good information about most of the well-published GIS data is in the metadata. So one of the things we have to do, and we're going to be doing this, you know, for our whole county, the county that we're setting up to do BFEs in, we have to convert this to feet, because this is meters. So how do we do that? Well, before we get too far along, let's bring up this information that we have on from StreamStats and take a look at it. This is the report. So it has so much good information in it and we're going to be using it. So let me put that aside. Let me open up this normal depth calculator. Now this is very similar to what FEMA has provided a program for called Quick 2. And Quick 2 does way more than this online normal depth calculator. Matter of fact, I've called and talked to them about how this was done and for what. It's done to demonstrate, you know, aspects of the channel, and it doesn't have nearly as many variables that need solved as, you know, what we really need to do in the future. But it's a great example. So we want to solve for this water surface elevation. There's some values in here, and there's already some cross sections. But we're going to put our values in there for slope. We're going to put we'll just go ahead and make this 0.04. That's typically what we do. We put in our channel for the state without a site visit is 0.04. On Quick 2, there's actually 3 Mannings in values. You have left and right bank plus the channel. So you can see that this one only has 1. So that's another reason why this probably wouldn't get certified by FEMA as an acceptable model. But you never know, you know, it could be modified. And then we're looking at flow. So we're going to get flow from StreamStats. We already got the channel Mannings in value in there. We're going to get the flow and the slope from that web portal that we were just looking at, StreamStats. It's going to come from here. So let's just go ahead and start putting it in there. Let's go back to, where were we? Where's the, oh, I think it's right here. Normal depth calculator. What's the slope? So we'll open this document for the slope. The slope is 83.2 feet per mile. So to make that a slope, we have to divide that by how many feet are in a mile. So 83.2 divided by, and I'm going to put all this stuff on the internet too, so you can have it, 5,280 foot. So divided by, paste, equals. So that's my slope right there. I'm going to go ahead and put that in there. Slope. Bam. It's in there. Oop, look at that. It came down. So now all we got left is the flow. And that's an easy one. No conversion there. Peak flow for the 100 year, 374. Bam. Uh-oh, it's coming down. We already got a water surface elevation already, 830. Now this is actually based on these cross sections. So all we have to do now is update these cross sections. And it's the station and distance in feet. So I'm going to pull that out of right here. So, but the first thing I have to do is change our DEM that we downloaded to feet. Well, how do we do that? Well, I'm going to open up the Raster Calculator. Amazing thing. This is a whole grid cell reference of this entire area in meters. And I'm going to change it to feet by multiplying it by 3.2808 right here. And these are easily found on the internet. I think I like Bing a lot. Google does it too. I like Bing because it takes it out to more decimal points. I like my decimal points. This one takes it out a long way, and that's great. So I'm going to make a new file here. This is the file I'm working on right here. It's in this calculator right as this value. And I'm going to export the same type of image file. I'm just going to put it back in the same directory. The only thing I'm going to do different is I'm going to put feet on the end of it. FT, save, and run. And there it goes. And it doesn't take long. This is just a one quad sheet area, so it doesn't take long. It'll take longer than that when we're doing the whole county. So I'm just going to go ahead and remove this meters one, because we're not working in meters, we're going to be working in feet. And you can see it looks the same. The difference is these values right here. And so now what I'm going to do is go down to here where our point of interest is. This is where the cross section, I've already placed a cross section here to make it more helpful to us. But you can, there's different ways you can place that. I can create a temporary cross section and just pop it right in there. But I usually like to keep a good record and to show people how it was calculated if they look at my records. So I would probably maintain this cross section somehow, whether it would be just 2 coordinate points that are documented or a shapefile. I want to document it. And then I'm going to use the profile tool. Now this profile tool is, I think it is actually loaded when you get QGIS, but if not, it's under plugins, and you can manage the plugins and go and find that profile tool if you don't have it and load it. So you would just hit profile tool and install it. Right now it's already installed. And the thing I've had to get used to in QGIS is, you know, how it manages and uses layers. So by default, your highlighted layer is what a tool is acting on. A little bit different than our map, but definitely effective. So I'm going to highlight the DEM. I'll launch the tool. I'm going to add that layer since I already have it highlighted, and then I'm going to select the cross section, and I'm going to select, tell it to select a polyline, and then I'm going to go up there and tell it to select that cross section, and bam, there's my cross section in feet. Here it is. You can see the Y is the elevation and the X is the profile. Look how that moves. I think it's so cool. And look at it, it's linked to the cross section up here at the top. When I move it, I can go to the stream, and even I can go to the deepest part of the profile, which most of the time is the stream. You know, and I can see it visually up there. So that's pretty neat. But that's not what I want to show you. Now I can go to the table. Look at this. Copy to clipboard. Bam. And now I'm going to go back to here where we got our cross section. I'm going to remove all those, and I'm going to put R's in there, paste it right in there, and then I'm going to tell it to update. And there it is. There is our profile. So we got our flow 374. Make sure that's right. Our slope. Manning's end value 0.04. Our slope we calculated. So this is our elevation right here. Now this isn't a regulatory BFE, but it is a BFE for this location as calculated by this software that I showed you. Pretty much very quickly, pretty much all of it is web-based. If it wasn't for the issue with having stations in miles, we could have used that instead of even a QGIS tool. So this is neat. So now we have this elevation, 1079.71. I'm going to copy that and go back over here into my QGIS and show you how I usually use this when I want to visualize it. So I'm going to go to the DEM, and I want to show that elevation value. So I'm going to go to, where will I go to? The style. Yeah, here it is. Under style, I'm just going to tell it to, I want it to be clipped to minimum and max, and I want the maximum to be our value. I'm going to hit apply. Oh, it's looking good. I'm going to make it red because I think it needs to be red. I'm going to set the transparency to about 50%. And there we have it. Now this BFEI calculator is only really good for this area right here, because once you go up and downstream, the slope becomes a factor, and it doesn't stay that elevation as it moves up and downstream. So it's only really valid for that cross section, maybe a few feet, 50 feet left or up and down, but not much. It's really based on how steep the slope is and how accurate that is. But we know that's the elevation right here. And now I'm going to turn on some aerial photography so we can see this. We're looking at and how that looks. So that's amazing. That's it right there. This is how it affects this. This is the floodplain right there for a 100-year non-regulatory flood. And the interesting thing is, and I've loaded this to show you this, but here is the NFHL. This is in a zone X. So even though the FEMA maps create a regulatory floodplain, it doesn't mean that you're not going to get flooded there. It just means that those maps are being used for insurance purposes. You can get flooded anywhere, and this is proof of that. This is a 100-year regulatory floodplain there. And this is probably a natural floodplain, as you would see, if you had loaded the soil type data there. You would see that. But generally, the only place where they create the maps for are places that had historical flooding events. So that's the difference. But it doesn't mean you're not going to flood. So anyway, I think that's it. I think we have it all put together now, and I'm looking forward to showing you how we move forward with manipulating these raster data sets to set up this tool so that we can calculate this flood risk in our counties. And that's all I have. Thank you.